functions, service functions. So what are the registers it uses? So for this particular interrupt, it uses the higher accumulator as well as the lower data register and the data register itself. So let's start with move AH1, interrupt 21H. So in this case, whenever you input a particular character, so this is for input a character, whatever character you inputted will be saved in the AL. So for example, so let's have an example. So let me just click here and clear the screen and go to the debug. So whenever you assemble at memory location 1, 10, 20, move AH1, okay, interrupt 21. Okay. So let's rip at memory location 120. So R, it points to the correct instruction. So trace and P. So whenever you have interrupt 21 or any interrupt, you use the P command or the proceed command. So as you can see, you will see the prompt ticking. That means it expects an input. So take note the content of your AL. So AL as of the moment is 0, 0. So I will input, say for example, 9. Okay, so as you can see, your accumulator changes from 00 to 139. So as you can see, accumulator changes from 00 to 39. Okay, so that is inputting a character. So now we want to output the content, the inputted character. So we want to output a character. So to do that we have the AH that is 02 and so DL this time will contain the character that we would like to output. So this can be a immediate addressing. What do I mean by immediate? You get a value. It can also be a memory location. Okay, so a memory location, or it can also be coming from a register. Okay, so for this example, this is an immediate value. Okay, so let's have an example. So let's output the so let's assemble, say for example, so let's assemble, so move AH2, okay, move DL, so lowercase a is 61 hexadecimal, so interrupt 21. So let's output, so R, let's trace, and let's P proceed. So as you can see, it outputs the immediate value A. So remember we saved earlier a value in AL, correct? So as you can see, the value of AL already overwritten because we've already changed the content, correct? So say I would like to move AH, assemble again. So move AH1, interrupt 21H, okay? Then move AH2, so move DL, whatever the content of AL, interrupt 21. Okay, so here is what we call the register addressing. So the value is coming from a register. So let's see the content. So move AH1. So R, so trace. Okay, proceed. So it expects an input. So let's input 8. So let's trace, move AH2. So whatever the content of AL will be moved to the DL. So DL currently has 61. So trace. Now it changes from 61 to 38. Okay, and then proceed. Now we have a value of 8. Okay. So let's have the last example. Output a character, this time with the data coming from the memory. So let's use again the interrupt. So move, say AH1, so interrupt 21H. So where's the data saved? In the AL. So this time I will save whatever I'll save whatever the data inputted or the character inputted at memory location 100. Okay, now let's output. So move AH2. So move DL, whatever the content of memory location 100, and then interrupt 21. So let's see our read. So at memory location 134, so let's trace, proceed, say I enter R. Okay, so R is 72. It is saved in memory location T. So let's display memory location 100. Memory location 0, 100. I input the same thing R. Okay, so it already has a content. Okay, so I'll just clear the content of the memory register. So fill 102. So I will fill 102 11F with 0. So let's display the content. Now it's 0. What's the address? So unassemble 120. Okay, so we're done with this. So we're starting from where? We're starting at 134. So our RIP memory location 134. Okay, because we would like to execute or trace this part of the program. Okay, so we will input another value. So R, so points to the correct instruction, and then proceed. So this time I will enter D, uppercase D. So uppercase D is 44. So trace. So as you can see, since our address is 100, okay, we save the location to 100. It points now to the 100, which has a content of 44. So trace and then proceed. It outputs the character from D. So at this point, we can now use the move AH9 interrupt 21H. So this is for outputting a string. So to output a string, we will need the AH as well as the data register. However, in this case, we have to initialize the content what is the address of this. So this particular variable means this is an address in memory location. So for example, we enter at memory location 100 whatever your string. So rosemary. Okay, so this is the one we will be outputting. So we assemble. So so then we do this particular example. Okay, so to do that, we will be entering a value. So enter a value in memory location 100 this time with the content of rosemary. Okay, and assemble. So let's just continue the address. So move AH9. Load effective address TX. What is the address? So at memory location 100 and interrupt 21. Okay, so let's run. So let's make sure it points to the correct address of the instruction. So trace, and proceed. However, this will give you an error. Okay, what is that error? It gives you a garbage. Okay, so for you to be able to eliminate this. Okay, so in C++ you need to have \0 or the null string. So in assembly it has to be ended with $. So as you can see, how do we end this? So it's either we already declare. So for example, that's the data. Okay, before we can end. Before we can end, we need to insert here a dollar of the. So still we have memory location 100 with rosemary. Okay, so this time we would like to output at memory 120. So move AH9 load effective address tx, whatever the content of memory location 100, interrupt 21. Okay. So in this example, it will still give you an error. What is that error? It will produce a what do you call this? A garbage. So let's read at memory location 120. Check if it points to the correct address. So it correct instruction. So trace, and then proceed. So as you can see, it gives you the garbage or the special character. So what do we need to be able to output this without the character? We can do two things. Okay. So first, we can insert. So in E, we can insert at memory location that is Rosemary, that is $sign. Okay. Second one, we can program it. So we create a program. So let's do the what they call this, the what, the first example, the first method. So in this case, we enter in memory location 100, so Rosemary with $sign. Okay, so assemble at 120. So read 120. So it points to this instruction: trace, and proceed. So as you can see, no more garbage. Another way of solving this is we will program. Okay, so we will create a instruction. So using instruction or program. Okay, so how do we do that? Okay, so let me clear first the content of the memory location 100. So okay, so first let's change the content of the memory location. So it 100. So let's write here Mapua University. Okay, so the $sign will be overwritten. Okay, so $sign is not there. So the $sign is here. Okay, so that's why it stops here. Okay, so what we will do, we will insert. So let's assemble at 120. Where did we stop? At this 126. So the next address is at 128. So assemble at 128. I know so we have to insert before we output the string, we have to insert here. Okay, so we have to insert the $sign. Okay. So to do that, so we assemble again at memory location 120, and we move. What is the address of that? We know already the address is 100 plus how many characters is Rosemary? So the Mapua University. How many characters is this? Up to F, correct? So this is a byte. Okay, so which means okay, it gives you an error. So to resolve that, so you have move byte pointer. Okay, the memory location what will be the address is 100 to 11F. That is where the Mapua University is saved. So the next address will be 110 with the content of 24. And then of course move AH9, load effective address, the address of the data of the string 100, interrupt 21. So let's see. So let's verify. So we have to make sure that the address is at memory location 120. So R, okay, trace, and proceed. Okay, so now it only outputs Mapua University with no garbage in it. So you have to insert the $sign with that. So we will continue with this with the next topic.